We are now about to turn back from data flow to TensorFlow. We are now going to re-engineer the features that we discussed. Initially, we had not made use of the pickup date time, but we are going to change that. We are going to make use of both the day of the week and the time of the day. This is something which required some little work for us while pulling the data, and that's why we had changed our big query as well. Now that we do have the day of the week and the time of the day, we are going to combine these into a crossed column. Before we make use of the crossed column, we are going to discretize those values, making use of a sparse column with keys, that's for the day of the week, and a sparse column with integerized features, that's for the time of the day, that's the hour of the day. And we are going to do something similar for the pickup longitude and the pickup latitude. Once again, it makes sense to consider these two data points together, so we will create a crossed column from them. It also doesn't make a whole lot of sense to contain or to consider the exact values of the latitude and longitude, and so we are going to bucketize them, that is to lose some information by discretization. And we are going to do exactly the same for the drop off coordinates as well. Okay, so let's turn back to the code. We are now within our Python code. We are examining the directory called trainer. This sits inside taxifier, which in turn sits inside the feature engineering directory. Notice that there is a model.py, a setup.py, and a task.py. Let's open up the model.py, which as always contains the heart of the model. Here are the input columns, and this is where all of the real valued columns that we had made use of so far had been created. But wait, there's something a little new here. In addition to all of the previous columns, we've also defined two new features. The first of these is a sparse column with keys, that is for the day of the week. So this is a one-off layer that is made available to us by TensorFlow. It allows us to accept data in the form of strings. Those strings need to be in the list of keys, that is Sunday, Monday, and so on. And TensorFlow will convert that string data into a layer, and that will be a layer of type sparse column. Notice from the docs how the logic works. It will look up the value of each individual data item in the list of keys. If the value is not found, a default value will be assigned, and that default value is -1 unless you override it. Notice that there is also a way to specify a combiner, that is a way in which to calculate some value based on the string value. We aren't making use of that for now. We do something very similar for the time. We just make use of a different column here. We make use of a sparse column with integerized features. That's because we know that the time data is going to have a specific range. It's going to be an integer between 0 and 23. A quick look at the docs for this particular type of column, that is sparse column with integerized feature, tells us that we should only use it when our features are already pre-integerized into int64 IDs. And that is of course the case here, and that's why it's safe for us to make use of this type of layer. Let's keep going. We now have defined features for the day of the week and the time of the day. The other features for the latitude and longitude and so on, those are as before. We have real valued columns for the difference between the latitude and longitude differences, as well as for the pickup and drop off coordinates and the number of passengers. Let's keep moving, and now something else that's pretty interesting. We are now going to bucketize those values of the pickup and drop off coordinates. So as you can see in the lines of code highlighted on screen, we invoke the layers.bucketized column 4 times, once each for the pickup latitude, pickup longitude, drop off latitude, and drop off longitude. The whole point of bucketization of these coordinates is because we don't really care about the exact values of the latitude and the longitude. In fact, we end up with a much more robust model if we divide these values into buckets, that is, if we round these values off to the nearest integer. A quick look at the docs tells us that tf.contrib.layers.bucketized column is exactly what we were looking for. Notice that this is something that we could do ourselves, but having TensorFlow do it for us with this readily available bucketized column object is pretty useful. That still leaves a question though about the second argument that we pass in to the bucketized columns. Notice that lat buckets and lon buckets over on the extreme right of the highlighted code. What are those all about? Well, it turns out that those are simply lists of the acceptable values that we want to bin our data or bucketize our data into. Lat buckets and lon buckets are defined right above. Each of them is created using the np.linspace method, that is numpy's linspace method. We can quickly look up the docs, but even a quick look at the code tells us that this method is going to return a list. That list is going to return evenly spaced values between the smallest and the largest possible values in that column. So for instance, lat buckets is going to be a list. Within that list, there will be values of the acceptable latitude starting from 38 and ending at 42, equally spaced and divided into the number of buckets that we specify. And here very quickly is a look at the docs for numpy.linspace. As we just saw, it returns evenly spaced numbers over a specified interval. We do need to invoke the .to list on the results of numpy.linspace, and that is how we get lat buckets and lon buckets to be the lists which we are going to have to pass in to our bucketized columns. So we have bucketized the coordinates, but we have yet to construct a new type of feature in which we consider the latitude and the longitude as a unit or as a tuple. And this is done in the next bit of code that's highlighted. This creates layers of the cross column variety. Cross column layers consist of more than one feature. Effectively, they are going to consider multiple features into one compound feature, in this case, a pair. Each feature value is going to consist of a pair consisting of a latitude as well as a longitude. Here's a quick look at the TensorFlow docs for this particular layer, and it confirms what we already witnessed, that it returns a crossed column. This is effectively a cross product of multiple individual columns which are passed in. There are also various other features which we won't use right now. Notice the first and most important argument here is columns, that is an iterable of feature columns. An iterable could simply be a list. These could be sparse columns, cross columns, or bucketized columns. And so we can see that it's possible to create crossed columns of crossed columns. So this could give rise to a pretty interesting hierarchy of features for our model. In our example, that list of columns is going to consist of the latitude and the longitude. We are doing this twice, once each for the pickup and the drop off location. So we have two crossed columns. Each of them takes in the corresponding latitude and longitude. The second value that we need to pass in corresponds to the total number of values for our cross. This corresponds to the hash buckets parameter from the function we just saw. Here, that is going to be number of buckets squared. Finally, we create a compound crossed column. This is a cross of two crosses that is done in the PD underscore pair line that is highlighted on screen now. We discussed just a moment ago that it is possible for crossed columns to take in other crossed columns, and that's exactly what's in action. Also notice that the number of hash buckets is now the number of buckets raised to the power 4. Let's also go ahead and do the same for the day of the hour. This is a crossed column with two input columns. Each of these is a simple column, the day of the week and the hour of the day.